Welcome back to Algebra 1 Honors. We're going to talk about Chapter 9, and I want to give you an example sort of as an introduction here. What Chapter 9 is all about is systems of equations. Okay, so let's imagine for a minute, and I forgot to bring my little Beanie Baby cows with me this morning, but let's imagine that you're looking at a stable, okay, a barn. And in that barn there are only cows and people. Okay, cows and people. The cows are in their stalls and people are walking around. Now, you go in and you count. And there are only cows and people, and cows only have one head each, and people only have one head each. There are no two-headed people, and there are no two-headed cows. Okay, so no deformed people or cows. And you count, and you get a total of 10 heads. Okay, now, if we go back and think about our equation that we would write there, if we use C as one of our variables to stand for the number of cows, okay, and P, as it sounds like people, to represent the number of people that we have. Let me do that in black because that doesn't look like it's showing up very well. So there's our C representing cows and our P representing our number of people. And when you counted, you got 10. That means if you add the number of people and the number of cows together, so we put a plus right there, we get 10. Now, that's using our variables and translating our word problem, because this would be written if you were doing it in the book, into an equation. What we have there is C plus P equals 10. Now, that's one equation with two variables. So if you think about that, if I just told you there are 10 cows and people in there and asked you to give me an answer as to how many cows and how many people, well, with one equation and two linear, that means no squares here, and two linear variables, there are lots of different answers, right? There might be no cows at all. Maybe I was fooling you. There's all people in there. Very boring barn, okay? Or there might be no people and lots of cows, 10 cows. Okay, or there might be a mix. Maybe each person has a pet cow, you know, so there might be 5 people and 5 cows. But you can see that with two variables and only one equation, we have lots of possible answers. Okay? Now, I'd also like you to think for a minute, and we're going to use this in a second, that if we replace the C and the P with X and Y like you're used to, we'd have the equation of a line there. Remember, because we've got two variables, they're both linear, they both have a little exponent of 1 that we don't write, equal to a number. So that's actually the equation of, it's not going to be exactly a line because we don't have half a person and half a cow, but it'd be dots, but they're going to be in a line. Okay? Now, lots of different answers though. So we're going to add a new flavor here, which is what Chapter 9 is all about. If I added to that, I told you not only are there 10 heads in there in that barn, okay, but there are 34 feet. So you went around and you counted each cow foot and each person foot, okay? And again, people have only 2 feet, exactly 2 feet each, okay? And cows, there are no 3-legged cows, there are no 5-legged cows. They have 4 feet, okay? So if we went around and counted, and we counted all the people feet and all the cow feet, we get 34. Now, here are the possibilities, right? We could have no cows. If we had no cows, then in order to have 34 feet, we'd have to have 17 people, because each person's got 2 feet. What if we had one cow? Well, one cow kind of accounts for 2 people, right? The front and the back person. So we'd have 15 people. 2 times 15 would give us 30. And 1 times 4, 34 there. Or we might have 5 cows. All right, 5 cows would have 20 feet. That means we have 14 to make up with the people, so we'd have 7 people. Okay? Now again, we'd have lots of different answers if all I said to you was there are cows and people in the barn, and there are this many feet, how many people, how many cows. Okay? Now let's write the equation for this one. For this one, okay, what our words would translate into, our variables are still going to be C and P. We still have so many cows represented by a C and so many people represented by P. Those are our variables. Okay? Now, what we know over here, though, is that the number of feet is equal to 34. Now, if C is our number of cows, how do we find out how many cow feet there are? Well, cows each have 4 feet. So if C were a 2, we'd multiply 4 by 4 and get 8 feet. If C were a 10, we'd multiply it by 4 and get 40 feet. So the number of cow feet is 4 times our number of cows. Okay? Now then, people feet. People only have 2 feet. So our number of people feet is going to be 2 times the number of people that we have. If we have 10 people, we get 20 feet. Now, when I add the number of cow feet to the number of people feet, I get 34. And those are just numbers that I picked. Okay? Now, lots of answers over here, lots of answers over here. Okay? What you're going to learn in Chapter 9 is that if you have 2 variables and 2 equations, then you're going to come up with usually 1 answer. Okay? There are 2 exceptions to that, but for right now we're just going to worry about finding our 1 answer. And if you look over here, our common answer in both of our tables is where we have 7 cows and 3 people. And over here, 7 cows and 3 people. So 7, 3, or 7 cows and 3 people satisfies both requirements, both equations. Because if I put a 7 and a 3, 7 and 3, I get 10 in that equation. And if I put a 7 here, I get 28 feet. And a 3 here, I get 6 feet. 28 and 6, I get 34 feet. So my answer that satisfies both equations is right here. Now, in Chapter 9, you're going to learn 3 different ways. Okay? Instead of having to write tables out like this, you're going to learn 3 much faster ways to find this answer that simultaneously, and sometimes these are called simultaneous equations, answers both requirements. Okay? And you'll see these kind of problems, they'll give you coin problems and various other things like this. This is the animal version. Okay? Now, the first way you're going to learn to solve this is with graphing. Okay? So I want to show you what happens when we graph both of these. Here's our graph, and this is a little bit different because we only have whole people and whole cows. Okay? Here's our cow axis going this way. So this is how many cows we have, and this is how many people we have. Now first we're going to graph our table over here, our answers to our original question. Okay? So we could have 0 cows and 10 people. 0 cows would be here. 10 people would be right there. Okay? I might have 1 cow and 9 people. 1 cow would be here. 9 people right there. Okay? 2 cows and 8 people. There's 2 cows. 8 people. 3 cows. 7 people. 4 cows. 6 people. 5 cows and 5 people. Okay, and you can begin to see what's happening. You see how our dots are all lining up? If I were a better drawer, they would exactly line up. Okay, let's see, 6 cows and 4 people. 7 cows and 3 people. 8 cows and 2 people. 9 and 1. And 10 and 10. Okay, so if I were a better drawer, you could see that. We essentially have a line there. Miss Moran could draw better. Okay? And you'll have graph paper to do it with. So, all right, now let's graph our other solutions over there. Over here, we've got 0 cows and 17 people, because remember we're doing the feet on that one. So 17 people. Okay, and then we have 1 cow and 15 people. 1 cow. Right, and then 2 cows and 13 people. 2 cows, 13 people. Let's see, 3 cows and 11 people. 3 and 11. 4 cows and 9 people. Let's see. 5 cows and 7 people. 5 and 7. 6 cows and 5 people. Right there. Okay, 7, then 7 and 3. 7 and 3, right there. Okay, and then 8 cows and 1 person, right there. Okay, 8 and 1. So you see our other line going there. Okay, and again, you'll have graph paper, so it'll be much easier to do. And what do you notice about our lines and our solution here? 7, 3. That's this point right there, because that's cows and that's people. Okay? And that's Mr. Kiger sneezing. Okay. Now, what you should notice there is that our solution to our 2 equations, one way to find our solution instead of doing these tables is to simply graph our 2 lines there and look for where the 2 lines intersect. Okay? And that intersection point, where they intersect, that is our answer, our single answer to our system of equations. This equation and that equation make a system of equations. 2 variables, 2 equations. We can find one unique answer, 7 cows and 3 people. Okay? Only one equation and 2 variables, lots of different answers. All the answers that are on our lines. Okay? Now, I told you there are 2 exceptions to this intersection point. Okay? And I bet if you thought for a minute, you could figure out what they are. Okay? There's one situation where you're never going to have an intersection point with 2 lines. So you take your 2 equations and you graph them, and they never intersect. They never cross. Okay? Well, that's a situation where you have 2 parallel lines. So if we graphed our lines, okay? And our 2 lines that we graph, not this equation, but if we graph 2 and they're parallel, they happen to be parallel, then what we'll get is no answer to our system of equations. Okay? So that's the one anomalous or strange possibility, and you'll encounter one or 2 of those in your homework problems. Okay? And then the other possibility is they give you 2 equations, but they're really the same name, right, for one equation. So if I had, for example, x plus y equals 3, and then I multiplied everything by 2, 2x plus 2y equals 6. Those are really 2 different names for the same line. So however I graphed it, if I graphed the first one and then I graphed the second one, they're going to end up right on top of each other because they're really 2 different names for the same line. Okay? So if you have a system of equations like that, where you end up with 2 different names but the lines are the same line on top of each other, then every single solution, every point on that line works as an answer. Okay? So we're kind of back to the original situation where you can't narrow it down to only one answer because you really don't have 2 different lines. You have 2 different names for the same line. Okay? But most of the time, 90% of the time at least, 95% of the time, when you graph your 2 lines and you're going to find one intersection point, just like we did here. And that's your answer to your system of equations. Okay?